students, I Rajeshwari Shirkanhalli welcome you all in Nagesh Karasgi Orchid School channel. As you know, we are discussing chapter number 11, work and energy. We have already discussed everything related to work, and from last two sessions we are discussing about energy. Energy, we have seen that it exists in different forms. In this chapter you are studying about mechanical energy. We have already discussed the first type of mechanical energy, that is kinetic energy. Now we are discussing about potential energy. In the last session we have derived the expression for potential energy. Potential energy in short called as EP, and it is equal to mgh, where m is mass, g is acceleration due to gravity and h is the height. So, we have also seen that potential energy is similar for the objects which are raised at the same height, irrespective of the path taken to raise the objects at that particular height. So, we have seen one solid example also of finding potential energy. Now, we will see the next solid example, that is example 11.6. So, this is another solid example. Okay, so you are supposed to solve these examples in your notebook. Now, see, look at example 11.6. An object of mass 12 kg is at a certain height above the ground. So, what is given here? The mass of the object is given in 12 kg. Okay, so mass should be in kilogram. If it is given in gram or any other milligram, like that, any other unit, you need to convert it into kilogram. Okay, now here no conversion is required as it is given in kilogram. So, it is raised at a certain height above the ground. If the potential energy of an object is 480 joule. Okay, students, in the previous example we have calculated, we found potential energy, but here in this example potential energy is already given. So, how much it is? EP, that is equal to 480 joules. You have to find the height at which the object is with respect to the ground. So, you have to find the value of h, height, and g value is given 10 meter per second square or 10 ms raised to minus 2. So, let us see how to find that. What are the given things? Mass of the object, that is m, is equal to 12 kg. Then potential energy, which is denoted by the symbol EP, is equal to 480 joules. Then g value is also given, that is 10 ms raised to minus 2. You know the formula. What is the formula for potential energy? It is EP is equal to mgh. Okay, just substitute the values in this formula. EP is 480 joules, m value is 12 kg, g value is 10 meter per second square, and h you have to find. So, put h as it is. Just rearrange the formula. Okay, so 12 kg into 10 meter per second square. Multiply this both the terms, 12 into 10. 12 tens are 120. Take it to the left hand side. It will get divided to 480. So, h value is 480 joules divided by 120 kg meter per second square. All these units as it is you have to write. Okay. Now, do the cancellation. Here you can do the cancellation very easily. 0, 0 cancelled, 12 ones are 12, 12 fours are 48. So, you will get h value is 4 meter. So, the height is at 4 meter, height of the object is 4 meter. So, very easy formula, only as per the requirement you have to rearrange the formula and find the required value. Okay, so, after discussing about potential energy, now let us move to the next part of the chapter, that are various energy forms interconvertible? Let us see. You know that we can convert one form of energy into another. Let us see with the help of activities. Can we convert energy from one form to another? Yes. We find in nature a number of instances of conversion of energy from one form to another form, isn't it? By using one form of energy we can convert it into another form. So, let us see with the help of activities. Activity 11.13. Sit in small groups, discuss the various ways of energy conversion in nature. So, in nature we find that different forms of energy are there which gets converted into another form in the different situations. So, discuss the following questions in the group. So, the first one, how do green plants produce food? You know that green plants are called as autotrophs because they are able to produce their own food. How do they produce? By the help of process called as photosynthesis. You know though that what are the requirements to carry out this process of photosynthesis? What are the raw materials? They require solar energy, carbon dioxide, water, etc. So, the next question is, where do they get their energy from? They get their energy from sun, isn't it? So, the energy obtained from sun is called as solar energy. So, photosynthesis takes place only during the daytime, as you know, you have already learnt about it. And why it takes place only during daytime? Because only during daytime sun is present. So, solar energy is available only during the daytime. Next question is, why does the air move from place to place? So, what do you feel? Why the air moves from place to place? That is actually because it also gets an energy which is called as wind energy. Because sun heats the surface of earth unevenly. As you know that uneven heating of the surface of earth takes place by sun. Sunlight does not heat the air directly. Sunlight heats the surface of the earth. It does not heat the air directly. It heats the surface of earth, which heats up and heats the air in turn. Okay, so, air gets heated and then it starts moving. You are familiar with the concepts like sea breeze and land breeze. Similarly, winds occur because of moving air. Now, the next question is, how are fuels such as coal and petroleum are formed? How are they formed? You have learnt in your lower class that coal and petroleum are formed by decaying of dead vegetation, and during that case more heat and pressure is applied. So, because of increase in the heat and pressure, coal and petroleum are formed. Next is, what kinds of energy conversions sustain the water cycle? So, what happens in the water cycle exactly? Potential energy is converted to kinetic energy and heat energy. You know that when there is a rainfall, potential energy gets converted to kinetic energy. In the water cycle, energy is supplied by the sun, which drives evaporation. Okay, so, because of solar energy, the water from the reservoir get evaporated. The sun with the help of wind also supplies energy, which drives the weather systems, which moves the water vapors in the form of clouds. So, the cloud formation also takes place because of energy supplied by the sun. Through condensation, water vapor turns into raindrops. So, condensation and evaporation, these are the kind of energy conversions sustain water cycle. Okay, so, how water cycle is sustained? Because of condensation and evaporation, which are caused because of presence of solar energy. So, here as I have told that solar energy gets converted into heat energy, then it gets converted into potential energy, then kinetic energy, means one form of energy gets converted into another form. Now, let us move to the next activity, that is activity 11.14. Many of the human activities and the gadgets we use involve conversion of energy from one form to another form. So, we use different gadgets in our day-to-day life, and using these gadgets actually what we do, we convert one form of energy into another form. You have to make a list of such activities and gadgets. So, identify in each activity or gadget the kind of energy conversion that takes place. So, what can we include? The simple gadgets which we use at home. They are electric heater, geyser, toaster, etc. So, what happens in this? Electric energy gets converted to heat energy, isn't it? Similarly, we all use fan. So, what happens in the fan? Electric energy gets converted to kinetic energy, and because of that kinetic energy the blades of fan starts rotating. Next, we use different bulbs. What happens in the bulbs? There is again electric energy, isn't it? No bulb works in the absence of electricity. So, in the bulb what happens? Electric energy gets converted into light energy, isn't it? First electric energy gets converted to heat energy and then heat energy gets converted to light energy. Similarly, in other instruments like in loudspeakers, etc., electric energy gets converted to sound energy. In bursting crackers, chemical energy gets converted to light energy, heat energy and sound energy. So, there are many things. You can make a list of those, all the gadgets and different activities with the help of which you can understand that energy conversion takes place in day to day life also. Okay, so, after seeing those activities, let us move to the next concept of the chapter, that is law of conservation of energy. Okay, so, what is the law of conservation of energy? In activities 11.13 and 11.14, we learnt that the form of energy can be changed from one form to another form. Then what happens to the total energy of a system during or after the process? Okay, in these different activities we have discussed that one form of energy gets converted into another form. But what happens to the total energy before and after this conversion of the energy process? Whenever energy gets transformed, the total energy remains unchanged. Okay, so, during this conversion of one form of energy into another, only the conversion of energy takes place, but the total energy remains constant. It remains unchanged. This is the law of conservation of energy. So, according to this law, energy can only be converted from one form to another. It can neither be created or destroyed. So, what is this law of conservation of energy? States that the total energy remains constant, only one form of energy gets converted to another form, no new energy is created or no energy is destroyed. So, the total energy before and after the transformation remains the same. So, when one form of energy gets converted into another form, the total energy before and after that conversion of energy remains the same. So, there is no change in the total energy. And this law of conservation of energy is valid in all situations and for all kinds of transformations. Okay, so, it does not depend on any factor like change in materials or change in temperature, pressure, etc. It remains same in all the situations. Similarly, any kind of energy when gets converted to any other kind of energy, this law is applicable to that. So, it is valid for all the energy conversions. Now, consider a simple example. Let an object of mass m be made to fall freely from a height h. Okay, so, consider that there is an object whose mass is m and it falls freely from a particular height h. At the start, the potential energy is mgh. You know that when an object is raised to a certain height, it has potential energy. And what is the value of potential energy? mgh. And at that time when the object is there at particular height, it is not in motion, it is not moving. So, kinetic energy is 0. Why is the kinetic energy 0? Because its velocity is 0, it is not moving, isn't it? It is 0 because its velocity is 0. we have derived the expression for kinetic energy. What is kinetic energy? Ek is equal to half mv square, where v is velocity, and if you put the value of v in this expression, you will get Ek is equal to 0. So, when the object is present at a particular height h, the velocity is 0, so kinetic energy is 0. And what is the potential energy? It is equal to mgh. Okay. As it falls, its potential energy will change into kinetic energy. When the object start falling, it is set into motion, isn't it? Means the object is moving, and you know that all the moving objects possess kinetic energy. So, when it falls, the potential energy which is stored in the object at that particular height will start converting into kinetic energy. If v is the velocity of the object at a given instant, the kinetic energy would be half mv square. Okay, so, v is the velocity of the object at any instant, then kinetic energy Ek is equal to half mv square. As the fall of the object continues, the potential energy would decrease while the kinetic energy would increase. So, when the object starts falling, potential energy starts converting into kinetic energy, and that is why potential energy decreases and kinetic energy goes on increasing. When the object is about to reach the ground, means when the height is 0 and v will be the highest, velocity will be the highest. Therefore, the kinetic energy would be the largest and potential energy will be the least, because when the object is about to reach the ground, at that time all the potential energy gets converted to kinetic energy. So, kinetic energy would be the largest and potential energy be the least. However, the sum of potential energy and kinetic energy of the object would be the same at all points. So, what is the sum of potential energy and kinetic energy called in this case? It is total energy. So, total energy of the object would be the same at all the points, that is potential energy plus kinetic energy is equal to constant. Potential energy means you know it is mgh plus kinetic energy means it is half mv square. So, the value of mgh plus half mv square is equal to constant. So, this value, constant value, is nothing but the total energy. The sum of kinetic energy and potential energy of an object is its total mechanical energy. Okay, so, this total energy is the total mechanical energy. We find that during the free fall of the object, the decrease in potential energy at any point in its path appears as an equal amount of increase in kinetic energy. Okay, so, when the object is falling freely, as I have told that potential energy starts converting into kinetic energy. So, how much of the potential energy decreases, that much is the increase in kinetic energy. Here the effect of air resistance on the motion of the object has been ignored. So, here we are just considering the free fall. Okay, so, we are just considering about the kinetic and potential energies. As you know that air offers some resistance, but here in this case the effect of this air resistance on the motion of the object is ignored. There is thus a continual transformation of gravitational potential energy into kinetic energy. So, we have discussed in our previous session that gravitational potential energy is nothing but the potential energy of the object which is present at a certain height and it is opposite to the gravitational energy. So, this is called as gravitational potential energy, and when the object starts falling down, this gravitational potential energy converts into kinetic energy. So, there is a continual transformation of gravitational potential energy into kinetic energy. Okay, now students, there is another activity for you, that is activity 11.50. So, let us see what to do in this activity. An object of mass 20 kg is dropped from a height of 4 meter. Okay. So, the mass of the object is given 20 kg and the height is 4 meter. Fill in the blanks in the following table by computing the potential energy and kinetic energy in each case. So, here a table is given. In this table, you have to write down the values of potential energy and kinetic energy by calculating their energies. You know the formula for calculation of potential energy, that is EP is equal to mgh. Kinetic energy EK is equal to half mv square, means mv square upon 2. Then you have to add these both the values, that is EP and EK, means here you will get the total mechanical energy. Okay, so height is in meter and both the energies and the total energy are measured in joules. Now, here 4 instances are given. For example, when the height of the object is at 4 meter, then it is 3 meter, 2 meter, 1 meter and then just above the ground. So, you have to use this formula mgh. M value is given for 20 kg and g, for ease of the calculation you can take 10 meter per second square, the value of g, and h means whatever the values are given here you have to use, you will get the different values of EP. Similarly, here you can use the formula of EK and find out the kinetic energy. Then just add both the values. Now, for example, if for 4 meter the potential energy is 800 joules and kinetic energy is 0, because at the beginning V value is 0, then total you will get 800 plus 0 is 800. And suppose at the height the potential energy becomes 600, then kinetic energy becomes 200. 600 plus 200 is 800. Next case, this is 400, this is 400. So, sum is 800. And next, when the height is 1, potential energy is 200 and kinetic energy is 600. So, total is 800. And when the object is just above the ground, height is 0. So, potential energy is 0 and kinetic energy is 800. So, sum is 800. So, when you calculate this, you will find that in this column, that is the last column, the total mechanical energy is same, that is 800. Okay, so, for simplification you can use the value of g as 10 meter per second square. Now, think it over. What would have happened if nature had not allowed the transformation of energy? Okay, so, if one form of energy is not able to convert into another form, then what would have been happened? There is a view that life could not have been possible without transformation of energy. Do you agree with this? Yes, all of us have to agree, because of transformation of energy we can live the life. Otherwise, if the energy would have been not transformed, then no food would have been prepared by the plant, we would have been not got the energy by eating the food, and we would have been not got the heat, light, anything. So, because of absence of transformation of energy. So, after this, let us go to the next concept, that is rate of doing work. Do all of us work at the same rate? Definitely not. Do machines consume or transfer energy at the same rate? No. Agents that transfer energy to work at different rates are different. Let us understand this from the following activity. Okay, there is another activity, activity 11.6. Consider two children, say A and B. Okay, in this activity there are two children named A and B. Let us say that they weigh the same. Okay, so weight of their bodies is same. Both starts climbing up a rope separately. Both reach a height of 8 meter. Okay, so there are two children, their weights are same, they are climbing the rope and they both reach to same height, that is the height of 8 meter. Let us say A takes 15 seconds while B takes 20 seconds to accomplish the task. Okay, so for completing the task, A require 15 seconds and B require 20 seconds. Then what is the work done by each? Is the work done same? Yes, the work done is the same because both have climbed the rope and both have reached at the top, which is at the height of 8 meters. So, same kind of work is done. However, A has taken less time than B to do the work, isn't it? A has taken just 15 seconds and B has taken 20 seconds to do the same kind of work. Who has done more work in a given time, say in 1 second? Definitely the person who takes less time to accomplish the work is doing more work in 1 second. So, here more work is done in 15 seconds as compared to 20 seconds, means more work is done in 1 second by the first child, that is A, as compared to the second child, that is B. So, here as work done is similar, the total work done, but in particular given 1 second of time, more work is done by A as compared to B. A stronger person may do certain work in relatively less time, isn't it? If suppose you are climbing the staircase with your grandparents, grandfather or grandmother, definitely you will climb more faster as compared to your grandfather or grandmother. Why? Because you are more strong than them. So, a stronger person may do certain work in relatively less time. A more powerful vehicle would complete a journey in a shorter time than a less powerful one. So, here power is then another concept which is very important. If suppose there are two vehicles, one is a very powerful vehicle, then it can complete the journey in a shorter time, and whereas the other vehicle is suppose less powerful, then it takes more time to complete the same journey by following the same route. We talk of the power of vehicles like motorbikes and motor cars. The speed with which these vehicles change energy or do work is a basis for their classification. Power measures the speed of work done, that is how fast or slow work is done. So, what is power? It is the measure of work done. It measures how fast or slow the work is done. Power is defined as the rate of doing work or the rate of transfer of energy. So, if the question is asked to define power, what you have to write? Power is defined as the rate of doing work or the rate of transfer of energy. If an agent does a work W in time T, then power is given by the formula power is equal to work upon time. Power is denoted by the symbol P, work is denoted by the symbol W, and time is denoted by the symbol T. So, P is equal to W upon T. Now, what is the unit of the power? It is watt. It is also pronounced as watt. It is honored in the name of James Watt, who born in the year 1736 and passed away in 1819, having the symbol W. So, the symbol for unit of power is W. W stands for watt. 1 watt is the power of an agent which does work at the rate of 1 joule per second. Okay? We can say that power is 1 watt when the rate of consumption of energy is 1 joule per second. But do you know that there are different units used for specifying power? For smaller powers and for larger powers, there are different units about which we will discuss in the next session. So, students, what we have discussed today is we have seen solid examples of potential energy, then we have discussed a very important concept, that of transformation of one form of energy into another form. Then we have started with another topic, that is power. We have derived its expression. Power is nothing but work upon time. Its unit is watt. We will see the remaining units of the power and many more things related to this power in the next session. Today here we will stop. Thank you.